Let's take a look at how we draw a motion diagram. So the motion diagram always has an arrow representing an axis. It has a direction that shows us which way this arrow is pointing. And it always has a tick like this that represents the origin for the position measurements. So we have the origin, and then we have the positive x direction. Now, the information that we're given for this problem here is from a position graph. So here we have the same axis. So this axis and this axis are the same thing. This represents the origin on the position graph. So at event 1, so we have Isaac's trip along the hallway from the washroom towards our class. So at event 1, Isaac is located here. So in this case, he is far from the origin in the positive x direction. So that means he'll be starting way out here. So not near the origin, but over here. And that will be event number 1. The dots you can draw just above the axis, on the axis, just below the axis. That doesn't matter. Now later on, Isaac has been traveling closer to the origin. He hasn't quite reached the origin yet. Okay, that would be a point down here. So on our motion diagram, it's moving towards the origin, but hasn't reached the origin by event 2. So our class is probably located somewhere around here. Okay, there's event 2. Now in between these two events, he's walking at a steady pace. This is our assumption. And so the spacing of the dots in the motion diagram will be even. So we'll have an even or an equal spacing of dots between event 1 and event 2.